machines. These are the end application. You can see the ropes from roads. So we put a geotextile fabric beneath the earth so that the soil should not be pressed and the roads should be compatible and the water drainage should be perfect. These are the area of applications of our machines.
मैं भी पहली बार देख रहा हूँ।
Customer
रोटेट डिवाइस तो क्या हो रहा है? रोटेट डिवाइस तो क्या हो रहा है?
also known as jumbo bags, container bags, bulk bags. It's the same name. These are the three-dimensional bag. That means these bags just like a box. Flexible because these bags are collapsible. A empty bag without fill, we can fold it, just like a paper. Intermediate because it is not big enough to carry bulk quantity, just like our normal containers in 20 feet, 40 feet carry. These are intermediate sizes. The carrying capacity of bags ranges from 500 kilogram to 2.5 ton. That means we can fill material in these bags which can withstand the load bearing of a 2.5 ton material. The bags are made mostly from polypropylene, and polypropylene is a plastics polymer, and I have taken this theme under utilization of plastics and polymeric materials. The FIBC work, just this is a background how this bag came into picture. The FIBC bag was first manufactured in the year 1970s. There is controversy about this, who made it first. The early period FIBC were made from heavy duty nylon and polyester coated with PVC. The initial cost of FIBC were very high, and therefore these were designed for use and repeat use for several times in a closed circuit, subject to certain conditions. As the earlier speaker was speaking on the circular economy and reuse. So in FIBC, this concept is now much more important to study. Because if we make a bag in such a way that can be used repeatedly, then so that 2 times, 3 times, that means you are reducing the consumption by 1/3. But to use a bag for repeatedly, it needs certain properties to be enhanced. That's mainly the mechanical properties, which can be enhanced by the machines and specific materials. For material front, the polymer companies, master-based companies are doing their research how to improve the bag mechanical properties. And the machine side, we are also working on our explore screw designs so that the weld homogeneous mixing and pumping will be better for good properties. I just took this point because the concept is circular economy. So we are also doing a lot of development on this FIBC, how to be used multiple times. Advantage of FIBC, strength weight ratio. This is not for FIBC, this is basically for plastics. The plastics are biggest advantage because it has a better strength weight ratio. What do you mean by strength weight ratio? Suppose if you take a stainless steel bucket to carry 20 liter material, 20 liter of water, So the bucket may be 2 to 3 kilo. But in case of plastic, you can do something with a 300, 400 bucket. That means with respect to strength and weight, the ratio, the plastic is better. Low cost of packing, mechanized filling and discharge operation. See, why these jumbo bags are mostly used in Europe, USA, other countries, less in India. Because we here in India do the packing in 25 kg, 50 kg, which are handled, transported by laborers. Because we have that workforce to afford loading the truck, unloading of the truck. But in Europe and USA, manpower is not plentifully available, so they try to do everything in a mechanical way. So when they fill the material jumbo bags 2 ton, 1 ton, so they handle the loaded bags with forklifts, material handling equipments. That's how we call it is mechanized filling and discharge operation. Saving loading and unloading time because you just push the forklift, take the material. You can unload the truck in 20 minutes, you have forklift. But if the same truck is filled with 25 kg, 50 kg, it should take much time. Material wastage because single bags properly packed, so individual bag turnover is avoided much. Flexible, collapsible, durable, eco-friendly. This is continued, some of the advantages of IBC. No pre-assembly required, better utilization of space, transportation of empty IBC cheaper, saving in packing cost based on multiple trip bags. As I told you, if we make a bag so strong, so it can be used 2 times, 3 times, so it will reduce the requirement. Low tire weight, that means the empty bags, it is because of its low strength to weight ratio. Application, simple type of FIBs are used for building materials, garbage and limestone. Medium FIBs are used for cement, fertilizer, chemical, detergent. Advanced FIBs are used for pharmaceuticals, hazardous goods, agro products, electrostatic, explosive and combustible powders. So you can see in each area there is the application of these bags. That means whatever items we are using on day-to-day, they are mostly packed in FIBs bags. In India, it is now increasing, but in other countries, it is already at a saturated stage. Application, there's some more applications. Special FIBCs like bags made with firm fit liners, specially liners. That means in some bags we need to protect the moisture to go inside. That's why you place special liners. FIBC bags are also designed, made with respect to applications like product type, solid, granular, normal, powder, fine powder, and product capacity. So for example, we need to fill cement. Cement is a powdery product, right? So when it will handle, there will be chance of leakage from the stitching, from the weaving. So that's why when we stitch it, we specially put some filler cuts. Those are floppy in their characteristic. They seal the stitching holes so that the powder leaking through the stitching is prevented. So for every type of bag and end-use application, there is some manufacturing technique to handle it. There are some bags which need breathability. That means it should have windows so that air can go inside, so that they have more shelf life. We call it ventilated bag. That means when the bag is made, there is some window given. It's not completely open, so that fresh air can go inside. There is a proper ventilation throughout the product. This is application, ventilated bag. Types of FIBC, single trip, uncoated, coated, without liner, with or without dustproof seams and having a safety factor of 5:1. A standard duty multi-trip FIBC, uncoated, coated, these are different types. A typical heavy duty multi-trip FIBC made from woven multifilament twisted yarn, polyester with a safety factor of 8:1. In the next slide, we will discuss about the safety factor. allostatic FIBC of any of the above categories and appropriately certified FIBC intended to for transportation of dangerous goods. When we transport the goods through ocean, so there are certain conditions to be fulfilled for these bags because we need some acids, chemicals. So during transportation, there should not some accident happens, so that it is taken care for this specific transportation of these goods. This is classification. There are by how many type of bags have been made. This is by shape. This is 4-panel, U-panel, baffle and round construction. I am just going to tell about baffle bags. See, FIBCs after fill, they are carried, transported to containers. The containers have a specific dimension, width, like 2.35 meter. So when we fill the container, we use 2 bags in a row. That is 2.3. The bag width should be 1.1 meter. Suppose we are filling some high density material inside the bag. So when you fill the material, the bag gets balls. Okay. So what happens when the bag balls? The container cannot accommodate second bag easily. Okay. That's why what we do, we put baffles. When you put baffles, that ties the wall to wall. So that when you put material, the material during the baffle windows go to the wall, but it does not make the bag to bulge. That's why this for this special application where high density we use baffle bags. Then by application, food grade bags, UN bags, multi-tip, shift proof, aerostatic bags and valve bags. One important subject static application. Type A, Type B, Type C, Type D. Type A, the normal bags. Type B, when you are filling any material at high pressure, high speed, there is some static charge generated. And the polypropylene, plastics material are non-conductible electricity. That's why some charge is developed. So when you are working, the charge developed, people get shocked. So to prevent this incidents, the bags are made with special additives so that these additives, how they work, they when you add these additives in the bag, they migrate to the surface and the additive is hygroscopic in nature. So that catches humidity, moisture in the humidity from the surrounding and neutralize the surface charge. That is type B. Type C, it is a conductive bag. But when you make this type of bags, you put a conductive yarn in the bag so that a conductive network path is created throughout the bag. And that conductive tape should have a background voltage below 6000 volt. Why this volt we have decided? Because when there is a hazardous zone, we are using filling combustible powders, gun powders, explosive powders. They have a very low ignition value. If you are filling the material and the background voltage is much more, so it will get ignited, catch fire. So if the background voltage is below 6000, that means with this voltage, that carbon tape will get conductive. Though it is normally it works insulator, but when the voltage is 6000 volt, it will conduct. It will be conductor and carry the static charge to ground. So when there is a static charge developed, it is immediately transferred to ground below 6000 kilovolt. And with this volt, the combustible powders cannot ignite. They can ignite if this voltage is more than 6000 kilovolt from safety point of view. So there is a low static clause. So as per that clause, studies have done. It has decided if you keep the background voltage below 6000, then it will help to conduct the static charge to take to the ground without any ignition. These are yarns which are electrically coated just like silver. They have a coronal discharge. So this is some upper portion of conductive bags. When the hazardous zones are more combustible, this type of bags are used there. This is designs how we lift the bags, kernel loop bags, cross kernel loop bags, single loop bags, tunnel loop bags. It is because depending upon the end user application, how customer handles unload the bags from truck. Single loop bags mostly used for fertilizer. In India, we pack fertilizer in 50 kg bags, but in outside like Brazil and bigger countries who are much into agro fields, they use such type of bags. FIBC designs. These are some designs how we make FIBC. Full open top. In this bags, the open is completely empty. Just like builder bag, because these bags are used and throw. Fill spout. It is for a control use. Suppose you want to put 1 ton material through a nozzle. Specifically, this is a fill spout. That means the bag is closed. Only for filling we keep a spout. Duffel top. This is a typical type of duffel. That means we are just reducing the opening from the bag. Top opening, just reducing. Fill spout. This is just outlet. This is discharge spout. Suppose you want to control the use. Suppose you have put 2 tons material, you fill it, and you to use some quantity now, 500 kilo. You then open the discharge, take 500 kilo, then close it. That means you can use just like it as you need the quantity. My cover style. This is the most important aspect of FIBC. See, FIBC are big bags, bulk bags. They are transported through containers, trucks, and sometimes maybe due to certain conditions they need to be stored outdoor. So basically, critical products are not stored outdoor, but maybe sometimes they need to be stored outdoor for some time. And in outdoor, as these bags are very heavy in quantity, so they need a lifting mechanism to lift. But what happens when you are putting the bag in the outdoor, there is a ultraviolet ray comes from solar spectrum. And these ultraviolet rays are very much harmful for the polypropylene. If you keep the bags outside, the ultraviolet rays damage the hydrocarbon bonds, so that the strength gets weak. And if you put a bag without ultraviolet stabilized for 6 months, 8 months in a strong summer season, it can be just a powder. If you just toss this bag, it will just a powder. That is too much damage happens to the bag. That's why in FIBC it is mandatory to have additives which will protect it from the sun ray, UV, especially UV lights. Because in sun ray there is a solar spectrum, we get a whole spectrum. We'll just in the next slide we'll see you, this is the total solar spectrum. Generally the visible right zone is from violet to red, wavelength from 400 nanometer to 700 nanometer, and below 400 is ultraviolet, beyond 700 is infrared. Infrareds generally the lamps are for high temperature, generally used for drying. But this below 4000, their ultraviolet rays, there are 3 categories, A, B, C. Ultraviolet radiation is 100 to 400 nanometer. Invisible to human eye is further split in 3 categories by UVA, UVB, UVC. Visible light wavelength 400 to 750 nanometer comprises of 7 colors that you know all big word. Infrared is beyond 750. So in this UVA, UVB, UVC, UVA is less harmful and UVC is not come to us, it is protected by the ozone layer. The UV comes to the air surface which constitutes 5% total solar spectrum. They are most damaging for the polypropylene, any plastic material. So what happens to protect these bags from ultraviolet radiation to maintain their mechanical properties, because ultimately these bags have a load bearing capacity. That means when you fill the bag and handle it, they should be able to bear that load in the bag. That's why we always maintain to retain the mechanical properties, means the tensile strength, because when you lift the bag, that is the force is applied on the bag, and the bag should have sufficient strength to withstand that load. That's why special ultraviolet master benches stabilizers are added in the bag to give a prolonged life. It doesn't mean you are adding the master bench, the bag will never fail, just like a normal bag. No, it will fail. But after a prolonged period, that means if you measure the strength without a ultraviolet stabilization, after keeping sunlight for 30 days, you may get 50% of retention of the original strength. But if you are adding master batch of ultraviolet, that strength can be retained up to 70-80%. This is the generally this stabilizer hall space, which we call hinder amino light stabilizers. That is a special master batch used in FIBC. Interestingly, this is global UV radiation, which is called kilo Langley per year. It is generally kilocalorie per centimeter square. Actually, depending upon the geographical location, we get the UV radiation. That means the ultraviolet rays, what do we get in India, very less in Europe. In India, typically it is 180 kilo Langley, Europe is 140. That means if I want to make a bag and keep in sun, in India, if it will fail in 6 months, in Europe it will fail in 1 year. It is the main factor, which is SWL and safe. What is this? See, safe working load means, this means that a bulk bag's safe working load is the amount of weight that the bag is rated and tested to hold safely. That means if I say 1 ton, then that bag must able to handle 1 ton of material should be filled inside it to be handled, transported, and see the bag once filled handled multiple times. When filled, it is loaded to truck, handled once. Unloading, it is handled another time. So during all these times, so if the bags are handled under mechanical lifting, it should be able to withstand that load. SF stands for safety factor, 5:1. Means, suppose we are making a bag of 1 ton, so we design that the basic safety factor should be 5 times more than the bag. That means when you make the bag, we typically test it, so we test 5,000 kilo strength the bag withstand. That's why we have specific test methods, just like in the electrical engineering. Suppose we are putting a fuse. If the circuit is drawing, suppose 50 ampere, we are putting a fuse of 200 safety factor means 200 amperes. This is everything we have a design, we have a safety factor to withstand sometimes the peak factors. But in FIBC, the safety factor is 5:1. This is for single trip use. If you making a bag and using it, putting material, then throwing it, it's okay. But you are going for a multiple trip means you are going to fill the bag, then you are going to discharge it, and again you want to use it 2 to 3 times. Then for that purpose, the safety factor should be 6:1. For what we do to increase the safety factor, generally we increase the material GSM, that is basically gram per square meter. That means we increase the grammage of the material we use. Thickness, linear, there are some different terminologies in this field. The manufacturing process of FIBC is very much similar to oven sacks bags production process, comprising the following steps: extrusion, tape production, weaving, fabric production, weaving, the belts we use in the bag, lamination, which are coated when moisture protection is required, bag making, that means assembly of cutting, painting, sealing the bags, assembly, insert of liner, tying the spouts, inspection of final bags, packing, making belts and hydraulic press, because these bags, as I told, is collapsible and they can, if not get compressed properly, they will occupy large volume So transporting in the container, they will occupy more volume. That's why these bags are packed in belling machine, compressed properly, so that more quantity can be stored in the container. This is the manufacturing of FIBC. Similar type of process I have showed in the another video, making tapes, fabric, lamination, printing. This similar type of video. Manufacturing of process of FIBC. This is first step is tape production from granules, and also many times we use certain additives to as per the requirement. Just I told, suppose it is ultra volume master batch. Sometimes anti-static master batch, just I told, for static charge generation in certain powders, when they are filled, they are highly static charge generated. Then this is the machine where we put the tapes made in the tape line and winder in the form of bobbins. Then a fabric is made in tubular form. We cut the fabric in the tube to make it in flat form. Then this is weaving, where the belts are made. The belts are attached in the belt, where the forklifts inserted to hold the belt. This is extrusion coating. If the fabric needs, suppose certain factories are more should be prevented for moisture, because just like fertilizer or any other products which have a adverse effect if they come in contact with moisture. So we need to protect them by coating the bags with another layer. Because when we are weaving the fabric, that's tape to tape weaving, there is a porosity in the bag normally. If we are filling normal things, they will not come out, because the porosity, that means the holes are small, closed, they will not allow the material to come out. But through that porosity, moisture can get entrapped inside the bag, and if you want, it should be no moisture should go inside, then these bags will be need coated. Then it is automatic cutting machine, where the fabrics made in the loom roll, they are cut into a specific length defined in the machine, and they cut as per their specified length, which is depends upon the bag size. This is printing. It is specially FIBC big bags and small quantities for each bags. So this is a manual operation, manual printing machine. This is the belt cutting machine, where you cut the weavings of a pre-decided length. This is the final section of the bag, where we assemble the bags. After all the components are get ready, they are sealed in the machines to give the final product as per the entire specification. The spouts, the bottoms, the baffles, the belts, everything. There are different components. For a single bag, the number of components comes from 5 to 10, 15. And they are each to be attached at different stages. Just like it is assembly line. Someone is attaching the bottom, someone is attaching the top, someone's spout. It is a continuous process, just like assembly line. Testing of FIBC for non-hazardous goods, that means single trip, as I have told earlier. FIBC are designed intended to be used for a one filling only. This bag cannot be reused, neither replacement of an inner liner nor repair of FIBC is relevant to this category. Actually, what happens? Cycle top lift test, 30 cycles of 2 times. That means when you say 5:1, then 30 cycles of load, 5:1. That means if the bag is designed for suppose 2 ton, 5 ton means 10 ton. That means we simulate the test with 10 tons on the material. That is 30 times. If that load is, if the bag withstand that load, then we call is qualified for a 5:1 load safety factor of 2 ton bags. This is other testing with 6:1. Just I was telling, when we switch to bag multiple use, then we have to engineering the bag with high duty cycle. That's why you see, we take the load of 70 cycles. In 5:1, we are simulating the load for 30 cycles. But here the same load will be given for 70 times. That means this bag can withstand 6 times load, so that it can be used multiple times. These are certification. Actually, I would like to share these bags are now coming in too much of certifications, because in Europe they have specially Euro Commission rules to follow the standards for these bags. Just like migration, that whatever this should be migration test, safety migration, overall migration, many certification, risk compliance, that in risk they are about 100 and more than 100 materials restricted not to use materials. So if you are doing FIBs means you have to comply many certifications. Food grade bag means you have to go for FDA complete compliance. You have very clean facility to make. So these FIBC bags as usually the advanced Western countries, the many regulations we followed. That's why if you want to going to bag fast, they will ask your certification, and you have to go for many different type of certification to comply to supply the bags to them. Finished? Now I will show you video how this process starts from granules till final bag. It is a short video of 5 minutes. So now what I have discussed, you will be able to see everything in this video, having more clear of the concepts. This video is especially our unit where these developments and things are going on. We have made a small video presentation. Testing of raw material. Starting it again. The factory side. These are the machineries. This is the tape extrusion line. Testing of fast input raw material. They are checking the melt for index. This is the tape line. For individual tapes, we will go inside oven to stretch it. This is the stretching unit. When we are increasing the mechanical properties, mainly the tensile strength, by stretching it, unidirectional direction. These are auto winders, winding the different packages. This is laboratory where we are confirming the bobbin quality. Condition in our where testing is done. This is laboratory where all tests are done. This is making the bobbins. controller. Everything on a field space. These are the fabric rolls. Then again the fabric is going for testing for confirmation. For the strength, GSM. This is the UV tester where we do for the UV stabilization properties.
Orientation.
Here we simulate the conditions of atmospheric conditions just like temperature, humidity, moisture, thermal shocks. We use the lamp which has the similar wavelength equal to the UVB, that is 295 nanometer. This is the coating station. Here we are doing the lamination on the fabric, especially in case of moisture protected bags. This is the printing machine. This is our machine made with collaboration with Pelican. This is the weaving, spells, loops. The belt cutting machine. Again, at each step there is a testing. When you make the product, different components we have testing for each product at each stage. Fabric cutting machine. That is from the baffle beds I am telling. This is the baffle cord openings where the fill material slips the wall through this hole, windows. The final assembly with all components after getting ready. Cortices, weavings, liners, everything. This is the cleaning any contaminants inside bags. They need to be air cleaned. It is compulsory for each bag to make it free from any contamination entrapped inside the bag. This is the inspection stage for dimensions. This is the test rig where you do the test for the safety factor load. You see, if it passes that I1, that means it's qualified. This is the belling machine we compress to make the bags compacted for controller load. This is a small bag, block bottom bags. There is one type small bag, just I am showing you how these bags are made. Very advanced bag. It is automatic. The bag has no stitch. It is sealed all from both sides. Then the final bells are going for the container stock. Thanks. It is all about my presentation. I have described the process, a small video, to make how the process is done. Thank you.
Thank you, sir, for sharing your impactful thoughts with us. Now, to express our heartfelt appreciation, we would now like to felicitate our esteemed speaker. May I kindly invite Professor Rajesh Katiyar sir, Professor Rathore sir, and Dr. Shastri sir to present a token of gratitude to our speaker.
अभी मेरे नाम देंगे
Thank you, sirs. We request you all to take lunch organized at. We will resume our lecture session after lunch by 3 p.m. Finally, assemble in the auditorium at 3 p.m.